All right, well, good morning, everyone. Welcome back to another exciting day of mathematics. So today we're going over our study guide. If there was ever a day that you paid attention, today's that day. So if you're gaming or whatever it is you're doing, right, Dominique, log off, tell your squad that blah, 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 you're going to study. Agenda for today, we're looking at the Algebra 2 Semester 1 Study Guide Cumulative Review. We're going to go all concepts and skills. And today's home play is basically to study the study guide, which is 7 problems only. But you're going to see how some of those problems have multiple processes and things that you need to do. Okay? All right. Your asynchronous code for today's session is GIA59, GIA59. And once again, your home play for tonight is to study your study guide, 7 problems only. All right, let's get started. Our objective for today, I can master all Algebra 2 concepts and skills for Semester 1. I can master all Algebra 2 concepts and skills for Semester 1. All right, so we reached this point. So let's see how we did with all the review of our processes and skills so far. So here goes problem number 1. Let's get started right away. Number 1, it says solve x over x plus 1 equals x minus 2 over negative x minus 1. Then it says check for extraneous solutions. Copy that. All right, here we go. It says solve. So the equation given is a rational equation, but the first thing that I usually check for is to see if it's a proportion. Do we have a fraction equal to another fraction? Yes, Mr. Q. All right, so then let's cross multiply. So I'm gonna multiply the x times negative x minus 1. So if we distribute the x to these two, we end up with negative x squared minus 1x equal. Next, I'm going to multiply x plus 1 and cross multiply that to x minus 2. I'm going to write it up here so you guys can see it. X plus 1 times x minus 2. If I multiply these out, distribute, that is x squared minus 2x. Distribute, that's 1x minus 2. If we combine negative 2x plus 1x, that leaves us with x squared minus 1x minus 2. At this point, we no longer have a rational equation, we have a quadratic equation. That means we need to set it equal to 0. If we set it equal to 0, that means that we need all terms on one side. But at this point, notice that we have an x squared on each side. So start with the smallest one. Which is the smallest x squared? Negative x squared or positive x squared? Now the negative. That means I'm going to add x squared to each side. And also I'm going to bring the negative 1x to the other side by adding 1x. Adding 1x. So we end up with 0 equals x squared plus x squared, that's 2x squared. Negative 1x plus 1x, that cancels, and we bring down the minus 2. So now we end up still with a quadratic equation. There's 3 different methods of solving quadratic equations. It's by graphing, by factoring, or by square roots. Right now I'm going to do factoring, but it's a binomial. Now, the shortcut to these binomials with a difference in between or a subtraction is we take the square root here, but we can't take square root of 2. It's a prime number. So if we factor, let's think about it. Can we check for GCF for these two right there? Yeah, what would be the greatest common factor between those two terms?
2.
We're left with x squared minus 1, and all that equal to 0. So let's continue factoring. Can we factor inside of the parentheses? Yes. So that means I can take now, if you notice it's a binomial, it's a squared and it's a minus. So let's see if we can take the square root of x squared. Can we take the square root of x squared? Yes, it's x times x. All right, square root of 1, that's 1 and 1, and one of them is positive, the other one's negative, bring down the 2, and all that equal to 0. All right, now that we're there, now we continue by setting each of these factors equal to 0. So I'm going to write 2 equal to 0, x plus 1 equal to 0, and x minus 1 equal to 0. So 2 does not equal 0, so that's, we get rid of that. Minus 1, x equals, x equals negative 1, plus 1, x equals 1. Is it coming back? You're like, oh yes, Mr. Q, these are my favorite, huh? Jaziel. All right. All right. Are we done? No, it says here to check for extraneous solution. What does that mean? Well, according to what we just did, x equals negative 1 and x equals plus 1. These are our possible solutions, but let's check for extraneous solutions. What does that mean, Mr. Q? That we need to check for our excluded values. So I write EV. And what do I do there? I bring my denominators from over here and set them equal to 0. X plus 1 equal to 0, and negative x minus 1 equal to 0. And we solve. So let's see. Minus 1, x equals negative 1, plus 1, negative x equals 1. Divide by negative 1 to get rid of that negative. So we end up with x equals negative 1, which is the same as over here. So our excluded value is negative 1. Now, what does that mean? Well, Mr. Q, it looks like the excluded value of negative 1, it looks the same as this negative 1, which means that's an extraneous solution, which means x equals negative 1 cannot be a solution. So we cross it out because it's an excluded value. So what does that mean? That means that x equals 1 is our only solution. Let's go. Good way to start, right? Am I right? Am I right? Yeah, all right. Let's move on. And now you see, guys, why we do the practice on the warm-ups, because all these concepts continue coming back. Okay, let's move on. Number 2. Copy this. It says 2. Given a polynomial divisor and dividend, use long division to find the quotient and remainder. First polynomial given is parentheses 2x cubed minus 10x squared plus x minus 5, close parentheses, divided by, open parentheses, x squared minus 5, close parentheses. All right. All right, so before we get started, the first thing that we need to check whenever we're dealing with polynomials, what did we say? I'm going to write it over here in blue. Make sure it's in what? Standard form. Standard form. Okay, so what does that mean? Well, I need to check. Let's see. What's the degree of this first term right here? Well, the exponent of the variable is 3, so this is third degree. What is the degree of this next term? 2. What is the degree of this one? An invisible 1, there it is. What is the degree of this one? 0. Okay. Is it in standard form from highest to lowest? Yes. Are there any any decimal placement missing? Let's see, we got 3. What's after 3? 2. What's after 2? 1. What's after 1? 0. No, there aren't any missing, and it's in standard form. Okay. Let's look at the other polynomial. What is the degree of the first term? 2. What is the degree of the last one? There's no variable, so it's 0. Is it in standard form? Yes, from 2 to 0, from highest to lowest. But is it missing any decimal placement in between? Yes, it's missing the 1. So I want you to do 1, put that in between and box it. And I'll show you why right now when we write our division, okay? Because we need to compensate for whatever's missing. So here we go. I'm going to write my first polynomial as my dividend. So I'm going to write 2x cubed minus 10x squared plus x minus 5 divided by, that's the one that goes inside the little house or whatever you guys want to call it. And then our divisor, I'm going to do that in blue. Look up really quick. The divisor, I start with x squared. However, which placement did we say was missing? The 1, power of 1, which means an x. Is that correct? So I'm going to put plus 0x. You guys remember that? You're like, oh, I remember, Mr. Q, I made a mistake back then. Yeah, but now you got it. And then we write minus 5. Okay. So now that we have our division set up, let's start dividing. I'm going to do my quotient up here in red. So I underline here the first placement, and I ask the question to myself, what number multiplies x squared that gives me 2x cubed? Oh, okay, it's 2x. Let's see, what is 2x times x squared? 2x cubed. That is correct. Okay. Next, what is 2x times 0x? Well, it's still 0, but it's x squared, 0x squared. And for right now, I'm not going to put plus or minus because 0 doesn't have a sign. Is that correct? Next, what is 2x times negative 5? That's negative 10x. Okay. All right, now check this out, guys. Look up to the screen really quick. Look up. Don't forget to do this. Put a little minus to indicate that we're going to subtract. You're saying, Mr. Q, we got this. No, I'm telling you, put the sign right there so it can remind you when you circle it to change the signs of everything that you just got right here. So we change this to negative. I'm going to do this one just to change it, and this becomes a positive. Because if you don't put this sign right here, I can almost assure you, because of the pressure in your noodle and also time or whatever, you're going to probably forget to distribute that negative. So what is 2x cubed minus 2x cubed? This cancels. Bring down the negative 10x squared. And 1x plus 10x, that's 11x. All right, and we bring the last term down, the last term being negative 5. And we do the process one more time. We start all over. We go up here to the next placement. And I ask myself, what number times x squared gives me negative 10x squared? Well, yeah, negative 10. Negative 10 times x squared, that's negative 10x squared. Negative 10 times 0x, that's 0x. And negative 10 times negative 5, that's positive 50. And once again, what did I ask you not to forget? To put the little negative over here, because we're going to subtract. And when you circle it, that's when you go, oh, I need to change all of these to their opposite. This becomes a positive, whatever, and then negative. Okay. So what is 10 minus 10? These cancel. We bring down the 11x. I'm going to do that in green because that's my last term. And negative 5 and negative 50, that's negative 55. Why did I change this to green? So it can register when we did this at the first time and I said this is the what? Remainder. You're like, oh, I remember, Mr. Q. Yeah. But how do we write our answer? Here we go. What is our quotient? What did we get up here? We got 2x minus 10. And then we fraction bar. What was our remainder? Our remainder was 11x minus 55 over our divisor. Look up. Instead of writing this one, I'm going to write the original one, which is what? X squared minus 5. And this is how we write our answer. Yeah, pretty good, right? Yes, Mr. Q. All right. And let's move on. That was number 2. Man, these are good, right? Here we go. Number 3. Factor the polynomial by grouping. They give us a polynomial x cubed plus 7x squared plus 6x plus 42. Once again, number 3, factor the polynomial by grouping. They give us x cubed plus 7x squared plus 6x plus 42. All right, here we go. Once again, make a little note for yourself. Since we are dealing with polynomials, we also make sure you check for standard form. Make sure they are in standard form before you start doing anything with them. So let's see. 3rd degree, 2nd degree, 1st degree, 0 degrees in a standard form. Yes, from greatest to least. All right, now we can get started. We're factoring by what? Grouping. So that means we're going to group 2 at a time, 2 at a time. So let's group the first 2 and the last 2. We're like, oh, Mr. Q, these are a piece of cake. I know. So at that point, check this out. Step 2, we're going to check for GCF for each of those groups. So look at the first 2. We got x cubed plus 7x squared. Is there a number that divides both terms other than 1? No. But does each term have at least an x? Yes. How about an x squared? Yes. How about an x cubed? No, only the first term has an x cubed. So that means the greatest for both is x squared. So what do I do with that? That means we're going to divide those 2 by x squared, divide by x squared. I'm going to write them right underneath so you guys can see it. So x cubed divided by x squared, that leaves us with 1x plus x squared divided by x squared is a giant 1, so that leaves us with 7. All right, plus, let's look at the next 2. We got 6x plus 42. Is there a GCF or a factor that divides both terms? Which is the greatest factor? 6. So if I'm going to write it right underneath each one, divided by 6, divided by 6, so you guys can see it. So what is 6 over 6? 1, so that leaves us with x. And what is 42 divided by 6? 7. Yeah. And once again, we're still not done. We're still checking for what? GCF. That's why I do this. Look up. I say, what is the same here, or what is common for the here and here? What is the same? Well, for both, x plus 7 and x plus 7 are the same, so that's x plus 7 is my first factor. And what's left over? We're left over with x squared and plus 6, x squared plus 6. That's my second factor, and that's why these are my factors. Yeah, let's go. And I know some of you are like, man, it's somehow I think I got this. Yeah, because we've been practicing. You know, unless you're copying your homework from someone. But other than that, if you've been practicing, then you got this. Yeah, you guys wouldn't copy from someone, right? No, Mr. Q. All right, good. All right, let's go to number 4. Number 4 reads, simplify the rational expression x minus 4 over x squared minus 10x plus 24. And then it says identify excluded values. And it's a beautiful day outside, guys. I'm outside. And if you hear me clapping, it's because I'm trying to get all the pigeons stay out of here because they're eating the seed of my grass, winter grass. So. And I also have my drones charged. I'm going to fly my drone so that they can chase them away. Woo. All right, here we go. So it says simplify the rational expression. So I'm going to write the rational expression again. We got x minus 4 over x squared minus 10x plus 24. On the side, I want you to write factor completely. We're going to factor completely the numerator and denominator in order for us to simplify. That's the first thing we're going to do. We're going to simplify first, and then at the end, we're going to do excluded values. So let's start with simplification. So let's look at the numerator. We got x minus 4. Is there a factor for each of these terms at GCF other than 1? No. So let's leave it as x minus 4. Okay, we're done. The denominator, it's a trinomial, so let's factor it. 24 goes on top and negative 10 underneath. So factors of 24, I'm going to write them next to. That's 1 times 24, 2 times 12, 3 times 8, 4 times 6. So think about it like this. Which pair of factors add or subtract to give us negative 10? So at first glance, my brain sees the 2 and the 12 and the 4 and the 6. Is that correct? Yeah, at first glance. But let's look now more in detail. The product has to be a positive, but the sum has to be a negative, which means that one of them or both of them need to be negative. So if I add or subtract 2 and 12, let's see, negative 2 and negative 12, that's negative 14. Yeah, they both have to be negative in order for 24 to be positive, so this cannot be. So let's check this one. Negative 4 times negative 6 is 24. Negative 4 and negative 6, that's negative, and yeah, that's it. So we take those, we write our factors underneath in the denominator, so that's x minus 4 and x minus 6. From there, last step for simplification, I'm going to do that in green over here. Step 2. Identify or ID giant 1. So do we have a giant 1 here? Yes, x minus 4 and x minus 4. X minus 4 and x minus 4. So what does that leave us with in the numerator? If we took this and we just have a giant 1, we're left with 1 on the numerator. In the denominator, we have x minus 6. And this is simplified. All right, so we're done with the first part, which is simplify. What is the next part? We need to identify the excluded value. So I'm going to do EV. And what do we do for the excluded values? We take the denominator and set it equal to 0 and solve. But look at the denominator. Look up, guys. The original one is a trinomial. And if we set it equal to 0, aren't we going to factor? Yes. So that means I'm not going to use the original one. I'm going to go next door to this, and it's already in factored form right here. You guys see that? Yes, Mr. Q. So bring these down and set them equal to 0 to save some time and space. So we got x minus 4 equal to 0, x minus 6 equal to 0, and solve. So that means plus 4, x equals to 4. Plus 6, x equals to 6. So my excluded values are 4 and 6. Let's go. How do I hit? It's too easy, too easy. Let's go. Yeah. It's like, I don't know, like a double-double animal style, no? Yeah. All right. Let's move on to that was number 4. We good so far, yeah? All right, before I continue, show me with fingers. I'll come to you with up to right there, numbers 1 through 4. How are you feeling? Yeah, 5s. Yeah, I should see like perfect scores. So, like I said, if you've been doing all the practice from the warm-ups that we do every day, because that's a lot of practice, to the home plays that you've been doing on your own, you shouldn't have an issue. Okay? All right, number 5. Yeah, let's go. And it reads, solve the equation 3x squared minus 6 equals 6 using the indicated method. Once again, number 5 reads, solve the equation 3x squared minus 6 equals 6 using the indicated method. Methods given is solve by graphing, and hopefully by now you already having your noodle to create a coordinate plane from -10 to 10 on both the x and the y. Part B is solved by factoring, and part C is solved by taking the square root. Okay, so those are the three different methods. I'm going to start with solving by square roots. Okay, and you're going to see why, because I remember when we first covered this and when we first solved three different ways, you're like, my favorite is by square roots, Mr. Q. All right, well, let's start with that one. Okay, because it's number one, it's probably the fastest and the funnest, yes. But like that, you are for sure knowing what your answers are on this one. All right, here we go. So I'm going to write again my equation here underneath where it says solve by taking the square root. So I'm going to write 3x squared minus 6 equal to 6. All right. For this method, solving by taking the square root, the most important thing, write this down, make sure you isolate variable. What does that mean, Mr. Q? That you need to leave the variable by itself. So draw a line down the equal sign, circle the 3x squared because we need to leave that by itself. What's around it? We have the negative 6, so we need to get rid of that. So we do what? Plus 6 plus 6. We end up with 3x squared equals to 12. Is there something next to x still? Yes, the 3. What is it doing? It's multiplying. How do we cancel that? Divide by 3, divide by 3. 3 over 3 is 1. We're left with x squared equals 2. 12 divided by 3 is 4. And last but not least, I'm going to switch to red. This is called the square root method because at the end we do what? Take the square root. And why, Mr. Q? Because a square root is the inverse of a square. So we end up with x equals, now check this out. Some of you are going to make this mistake. Some of you are just going to write 2. That is incorrect. You need to write what? Plus minus 2. Make a note, please. Or in other words, the solutions are x equals 2 and x equals negative 2. These are my solutions. How is that, Mr. Q? Well, square root of 4, what does that mean? What number times itself gave us 4? 2 times 2, 4. What is negative 2 times negative 2? 4. Okay. All right. Simple method, yes? Yes. That's why some of you like using this method. Let's move on to the next method, by factoring. I'm going to write the equation once more. 3x squared minus 6 equals 6. So quick recap on the method for solving by square roots. What was so important? That we need to isolate the variable. Okay? When solving by factoring, look up to the screen. When solving by factoring, the most important initial step is that we set it equal to 0. Equal to 0. All right, since we already have, line down the equal sign, since we already have 3x squared minus 6 on one side, let's just bring the other 6 to this side. So it's subtract 6, subtract 6. We're left with 3x squared minus 12 equal to 0. Yeah. And now we can start factoring. So here we go. I'm going to switch to green. Factoring. This is not a trinomial. We can't take the square roots. So what else can we do when factoring? Check for GCF. Is there a GCF between 3x squared and negative 12? Yes, it's 3. And we're left with parentheses x squared minus 4, close parentheses, equal to 0. Am I done? I'm going to switch to blue. No, inside of the parentheses, it looks like a difference of squares. Let me double check. Can we take the square root of x squared? Yes, it's x times x. Can we take the square root of 4? Yes, it's 2 and 2. One of them is positive, the other one is negative, and bring down the 3. All that equal to 0. And at that moment, your noodle should be able to kick in, right? So I'm going to continue over here, which means we set each one equal to 0 and solve. So 3 equal to 0. x plus 2 equal to 0, and x minus 2 equal to 0. 3 equal to 0, that is not true. We eliminate that. Minus 2, x equals negative 2, plus 2, x equals 2. And these are my what? Solutions. Do we have the same answer as the other method? Yes, because it's the same equation. All right, quick recap. By solving by square roots, what is the first initial thing that we need to do? Isolate the variable. For solving by factoring, what do we need to do? Set it equal to 0. Okay, let's go to the last method, which is by graphing. I'm going to do the notes in black for this one. To solve by graphing, we need to, number 1, set it equal to 0. And number 2, make 0 into y. Simple. So here we go. So I'm going to write my equation 3x squared minus 6 equal to 6. To set it equal to 0, line down the equal sign, I need to get the 6 to the other side, so I need to subtract 6, subtract 6. We're left with 3x squared minus 12 equal to 0. And the next step, we change the 0 to a y. So this is 3x squared minus 12 equals y. And why? Because we need to make a table. Here we go. X, y. So then we go for our domain. Remember, it's always negative 2, negative 1, 0, 1, and 2. All right. So let me show the work for negative 2 first. Let's substitute that in here for x, negative 2. So I'm going to switch to blue so you guys can see that. So negative 2. So in here, we're going to write 3 instead of x, open parentheses, negative 2 squared minus 12 equals y. Let's do the exponent first. What is negative 2 times negative 2? That's positive 4. And then we have 3 times 4 minus 12 equals y. What is 3 times 4? That's 12 minus 12 equals y. What is 12 minus 12? It's 0. So that goes right here. All right, let's do the next value. I'm going to do the next value in red so you guys can see the process in a different color. So here we go. So same equation. I'm going to take the same one, but I'm going to do 3 parentheses times negative 1 squared minus 12 equals y. So I'm working on negative 1. So what is negative 1 squared? That's 1. So we have 3 times 1 minus 12 equals y. So what is 3 times 1? That's 3 minus 12 equals y. What is 3 minus 12? That's negative 9 equals y. So that goes right there. Now for the day of the party, if you do at least 2, show me the work for 2, and the rest you can do in your noodle. We can do the rest in the noodle. So let's see. Follow along. I'm going to do the next one in green. 0. If I substitute in here into the parentheses instead of x. So what is 0 squared? 0. What is 3 times 0? 0. And that leaves us with what? Negative 12. Next one. 1. If I substitute 1 in here, so what is 1 squared? 1. What is 3 times 1? 3. What is 3 minus 12? That's negative 9. And the last one, substitute 2 for x. What is 2 squared? 4. What is 3 times 4? 12. What is 12 minus 12? 0. Now, if some of you want to do the work and show the work for all of them just to make sure, that's fine. But I want to see at least the work for 2 of them, okay? All right, let's graph this. Let's create a little coordinate plane over here. All right, so let's see. The domain we have from -2, -1, 0, 1, and 2. So on the x, I'm going to go to -2, -1, 1, 2. Is that a little crooked? It is, right? Or is it me? Anyways, I'll leave it as is. I don't want to mess with it. The y, look at the range. It goes from 0 all the way to -12. No positives, so that means I'm going to go from 0, I'm going to go down -1, -2, -3, -4, -5, -6, -7, -8, -9, -10, -11, -12. All right. All right, let's plot our graph. I'm going to do that in blue. So the first coordinate, or the first point, is -2, 0, -2, 0. It's right there. Next one, -1, -9, -1, -9, which is right there. Next one, 0, -12, 0, -12, which is down here. Next one, 1, -9, 1, -9. Next one, 2, 0, 2, 0. Let's graph our parabola. Are we done? No, Mr.Q. All right, so that means you're gonna point arrows there and there. Where are we pointing to? To x -2 and to x of 2, where the parabola is crossing the x-axis. These are my solutions, also known as x-intercepts. That's how we know they are the solutions. And on the table, look at the table. Where are those solutions at? At -2, 0, you can box that, and 2, 0, you can box that. That's how we know those are the solutions. Did we get the same thing as the other methods? Yes, Mr. Q. Bam, let's go. Man, too easy. We got this, yeah? All right, let's move on. That was number 5. Let's go to number 6. Number 6. Bam, let's go. And it reads, number 6, answer all parts including the table. A fireworks projectile is launched at 20 meters per second from a 6-meter cliff. The table shows a height, y, in meters. The projectile is above a field after x seconds. And they give us a table. Copy the table. You don't have to copy the word problem, but copy the table first. The table has time in seconds, and it's 0, 1, 2, 3, 4, 5. And underneath that, it has height in meters, 60, 75, 80, 75, 60, 35. And also make one of these, they give us quadrant 1 from the coordinate plane. The x values, it goes from 0 to 11 by ones. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And on the y, it's for the height, and it goes by tens. 0, 10, 20, 30, 40, 50, 60, and so on, all the way up to 110. And they have point A, it says plot the points and make a curve. Point B, what is the maximum height of the projectile? Point C, over what interval is the projectile's height increasing? Point D, over what interval is the projectile's height decreasing? And at the end, the table is indicating for us to find the domain and range in all 3 notations: inequality, set notation, interval notation. And then at the end, it says end behavior. Copy that, please. I'll give you guys a little bit of time. Go. All right. So let's see. It says a fire projectile is launched at 20 meters per second from a 60-meter cliff. The table shows the height y in meters, and the projectile is above a field after x seconds. Okay. So part A, they're asking us to plot the points and make a curve. So let's look at time in seconds. Time over here, it looks like it's X. So let's label our table so like that we know what we're looking at. The top values, which is in seconds, it's our X, and our height is our Y. Now that we have that, now we can go each one at a time. So when X is 0, Y is 60. So let's plot that, 0, 60. That's our first point. Next, 1 of X, 75 of Y, 1 second, 75 meters, which is right there. Next, 2 seconds, 80 meters, 2 seconds, 80 meters. 3 seconds, 75 meters, 3 seconds, 75. 4 seconds, 60 meters, 4 seconds, 60. 5 seconds, 35 meters, 5 seconds, 35 meters. All right, so let's make our curve from the left to right. There it is. All right, so we're done with part A, which is plotting and making the curve. Let's go to part B. What is the maximum height of the projectile? So in blue, look at it. It starts down here in 60, it goes up to here, and then it starts going down again. So the maximum height, I'm gonna point to it, which is max. Just gonna put max. First, I'm gonna write the coordinate, which is at 280. So I'm gonna put in parentheses 280, 280. However, the height is 80 meters. 80 meters. So what does the coordinate 280 mean, guys? What does it mean? 280. What do you think?
In 2 seconds, they got to 80 meters?
Yeah, in 2 seconds, it's at 80 meters. That is correct. All right. So we're done with part B. Let's go to part C. I'm going to switch to red. Part C, it says, over what interval, notice the vocabulary here, they wanted in what? Interval notation. Over what interval is the projectile's height increasing? All right, so let's start from here from 60. I'm gonna follow the curve that I just drew, and let's find out where it's increasing. So it starts here, it's increasing, 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 increasing up to right here. So let's start with the X values. From what X values is that graph increasing? It's going from 0 to what? To 2 seconds. So I'm gonna write that in interval notation from bracket 0, comma 2, bracket, and that's in seconds, comma. Can we write now the interval also increasing, but in the meters, in the height? Yeah, we start here and it stops over here. So that means the height starts at 60 and it ends at 60. So my interval is from bracket 60, comma 80, and that's in meters, meters.
Mr. Q, I have a quick question.
Yeah.
How are the brackets different from the parentheses again?
Okay, so the brackets here, since it's a solid point, it includes that value from here to here and from here to here. This one up here in part B, the parentheses is just indicating that it's a coordinate. That's because it's saying here, what is the maximum height of the projectile? It's at this coordinate, which is 28, 28. It's just a coordinate. Remember when we plot points, we need an X and a Y value? So we put them in parentheses. Now, if you were to write me an interval notation and you put parentheses, that's telling me that it's not including the points. It would be in, that means that the point here, it doesn't include 60 and it wouldn't include 80. So that means you put a parenthesis to indicate that. But in this case, since they are, it's brackets. Okay?
Thank you.
All right, guys, let's go to part D. In green, I want you to find me the interval in which the projectile is decreasing. When the projectile is decreasing, from where to where is it decreasing? I want it in seconds and I want it in meters. Should be just about done. So I'm going to follow the curve. I start at 60, and then from 60, it goes upward, and it stops there. But from here, it starts again, but it starts going downward, and it stops about right here. So at this point, I'm still at 2 seconds, and it stops at about 5 seconds. So my interval is bracket 2, comma 5 seconds. And in height, it started at 80, and it stopped at right here, which is 35. So bracket 80, comma 35, and that is meters. And that's where it decreased. Hands if you got that. Yeah, okay. All right, let's go with our domain and range. So I'm gonna get my highlighter just to make it a little bit different from what we highlight there. I mean, we followed with different colors on the curve. So for the domain, we know that we're focusing on the X values, and I start highlighting starting from the far left and going to the right. So what is the first point I encountered from left to right? The first point is right there, Mr. Q, at 60 of the height, or 0 of X, 60. And I start highlighting going to the right, and I'm going to stop at the last point. The last point is that one. All right, so what are my X values from 0 to what? So from 0 to 5, 0 to 5. So if it's from 0 to 5, and it includes those, so that means it's 0 less than or equal to X less than or equal to 5. In set notation, solution set of X, 0 less than or equal to X less than or equal to 5. In interval notation, bracket 0, comma 5, and bracket. Let's go with the range. I'm going to highlight from the bottom to the top. I'm going to change colors. So what is the first point I encounter from the bottom? Right here, Mr. Q, and I'm going to highlight going upward till I get to the last point being right there. So what are my Y values where it starts? From the bottom, it starts at 35 and it ends at 80. So that means this is 35 less than or equal to Y less than or equal to 80. Solution set of Y such that 35 less than or equal to Y less than or equal to 80. And set notation, I'm sorry, in interval notation, bracket 35, comma, 80, bracket. All right. All right, and last but not least, end behavior. Now remember when we did end behavior, we usually had X values going towards negative infinity. Is that correct? Do we have anything going towards the negative side? No, because we end up right here at the 0 of X. So I'm going to put for the left, no behavior. Because we're going right now for X values, right? How about for the right? Let's see. This graph starts at 0 of X and it stops at 5 of X. Yes, so I'm going to write as X approaches 5 because that's where it stops. Is that correct? As X approaches 5. Okay. What happens to Y, guys? We start at 60, but then it goes up and then all of a sudden it starts going downward. So Y approaches what?
A curve?
No, no, no. So look at here. As X approaches 5, Y approaches what?
80.
35?
35, yes. As X approaches 5, here we start at 60, it goes up to 80, but then all of a sudden it approaches at the end to 35. All right, that was number 6. Y'all ready for the last one? All right, here we go.
Mr. Q.
Yeah.
Oh, okay, never mind. I was gonna say, what did it say on the bottom? Because like it was kind of like didn't really read it.
It says left, no behavior, and then comma, X, arrow to the right, 5, y arrow to the right 35, which means as x approaches 5, y approaches 35. All right,
Thank you so much.
7, you're welcome. Number 7 reads, use a scatter plot that shows the average cycling speed as time passes. Use the points 5, 15, that's a coordinate, and 25, 10, that's another coordinate, to write the slope-intercept form of an equation for the line that fit shown in the scatter plot. So copy the graph, guys. The graph for the x-axis, it starts at 0. It goes all the way to 35 by 5. So it goes from 0 to 5, 10, 15, 20, 25, 30, 35, and it's labeled minutes. On the y-axis, it goes from 0 to 18, and it goes by 2s, and that's miles per hour. So it's 0, 2, 4, 6, 8, 10, 12, 14, 16, and 18. Reference points that they give us are 5, 15, 10, it looks like 13.5, and then 15, 11, 20, 10, and 25, 10. And then they draw a line going through the first point, which is 5, 15, and the last point being 25, 10. All right, so this one, they want us to write a slope-intercept form equation. So the key word here, they want, first of all, the slope, and then they want us to write the equation, So whenever they give you these two coordinates like this, they give us the coordinate 5, 15. I'm gonna label that on the graph, and the other coordinate 25, 10. I'm going to use a formula. So I have m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. M equals fraction bar, and then minus on top, minus on the bottom. And I'm going to label my points. This is x sub 1, y sub 1, which is 5 is x sub 1, 15 is y sub 1. And for the second coordinate, this is x sub 2, y sub 2. 25 being x sub 2, 10 y sub 2. All right, let's substitute values into our equation. We have y sub 2 minus y sub 1. So that is 10 minus 15. From there, x, we have x sub 2 minus x sub 1. So x sub 2 here is 25, and x sub 1 is 5. All right, so now that we have our fraction, what is 10 minus 15 on the numerator? That is negative 5. What is 20 minus 5 on the denominator? That's 20. M equals, so let's simplify negative 5 over 20, and that gives us negative 1 over 4. And what does that mean if we interpret the slope? If the y value, which is the rise, which is the y, is in miles, and the denominator is minutes, and they're talking about the average cycling speed, that means what? For every, 1 mile, in how many minutes? Mile, minutes, in 4 minutes. All right, let's write our equation. We have y equals mx plus b. I'm gonna write it again, y equals blank x. So what information do we need? The obvious one is the y-intercept. I don't know if you guys noticed on the graph, we didn't put the arrow all the way to the end. So let's extend it to see what our y-intercept could be. It looks like my y-intercept could be 16. So I'm just gonna write positive 16 there. And do we have a slope already? Yes, Mr. Q, it's negative 1 over 4. So I'm gonna write negative 1 over 4. And double check to see if that's true. Is it a negative slope? Is the line going downward? Yes, it's going downward. So that means it's a negative slope. All right, guys, that's our study guide. Show me where fingers, how come you are with those 7? 1 being the lowest, 5 being the highest? Yeah, 5s, yeah. Yeah, so once again, make sure as we approach next week is your final. Make sure you you go to the YouTube. I'm gonna upload this video. Make sure you go to the YouTube channel, watch the video again, but watch problem number 1, pause it before I show you the process, and you do it by yourself, and then play it again or get to the end of that problem and see if you got the correct answer. If not, make corrections and put a little start and go back to it again later on so you can practice again the process till you get it right. You know what I'm saying? And that's how you're gonna go with each of these problems, okay? All right, so I'm gonna stop right there, guys. Have a good afternoon, good study time over the weekend, and I'm gonna post this video like around 3:30ish as soon as I have a little break. All right, have a good one, guys. See you guys next week. Peace.